Hey guys, in this video I'm going to answer the following question. What is the best speech recognition API right now? I'm going to compare the speech recognition accuracy of the three big cloud providers, AWS, Google Cloud, and Microsoft Azure. We're also going to look at two startups focused on speech recognition accuracy, Assembly AI and DeepGram. Third, we're going to look at the free and open source OpenAI Whisper model for speech recognition. And finally, we'll compare these against the Google Gemini model, a large language model that is also capable of understanding audio. My name is Bai, I'm a machine learning engineer and a PhD in natural language processing. And in this video, let's see which one of these APIs and models are the most accurate in recognizing speech. I know you might be thinking, like, speech recognition, why are we doing this? There's gotta be lots of benchmarks on what's the best speech recognition model, right? Well, yes and no. So there are lots of papers on speech recognition, and they run some experiments and report the results. But in academic papers, they generally compare models and not APIs. And there's a good reason for this. APIs are black boxes, you don't know what's inside, and you don't know when they might change, and this is bad for publishing a paper. But practically, most application developers don't want to set up a model, they just want to call it an API. So I think a good and fair comparison of the major speech recognition APIs would be really useful for the community. I did find some blog posts that compare different speech-to-text APIs, but many of these blog posts are written by companies that are developing these APIs. Like DeepGram's blog post, if you scroll down to the results, you'll find that in their benchmark, DeepGram is the best performing model on every speech recognition category. And right, that's exactly what I expect from this. Clearly, any kind of blog post that's written by a company that's making a speech recognition API is going to be biased. In my case, I wanted to know exactly what was actually the best speech recognition API because I'm building VoiceWriter. VoiceWriter is a tool to help you write faster using voice. Simply speak your thoughts, and the AI will fix your grammar and add punctuation in real time. It uses advanced speech recognition models, just like the ones I'm benchmarking in this video, and I use it every day to write things much faster, including my emails and my daily stand-up updates. You can also use our Chrome extension to use VoiceWriter on any website. Try it for free at voicewriter.io. Once again, I'm not affiliated with any of these companies whose models I'm benchmarking. I simply want the best speech recognition experience for the users of VoiceWriter. Now back to the benchmark. I wanted to find a collection of audio clips that could test these APIs on a variety of audio conditions, like if there's noise, if the speaker has accents, if there is unusual words, etc. I also wanted the clips to be long enough to evaluate the performance on generating punctuation and capitalization, so not be so short that it's only one sentence. At first, I looked at some open source datasets. Here is a benchmark by Hugging Face called ESB that basically collects together a bunch of commonly used speech recognition datasets. This looked promising, but when I dug deeper, I found that these datasets were not quite what I was looking for. For example, the Common Voice dataset, it has a lot of accidented speech from people reading Wikipedia, but all of the clips are around 10 seconds long at max. Another commonly used dataset called LibreSpeech is from people reading LibriVox audiobooks. Because they're from public domain audiobooks, the language in these speech samples contain a lot of poetry and some unusual words that are not commonly seen in modern English. So I'm like, okay, whatever, let's just do it myself. So I spent a few hours looking for clips and transcripts and putting them together in Audacity. I decided to put together some samples of relatively clean English speech, some noisy speech samples, some with accents, and a few containing specialist language. Each of the clips were around 1 to 2 minutes long, and I found sources that had a transcript together with audio, and then I manually checked all the transcripts and corrected any problems with them. Obviously, this is not a very big sample size, but altogether it's around 30 minutes of speech, and I think it's good enough for this purpose. Condition 1 is clean English speech, and for this I used some audio clips and transcripts from TED Talks. This is a relatively clear speech from native speakers on topics that are not very difficult, so I expect this should be easy for all of these APIs. Here's an example of what this sounds like.
Why, how, what? This little idea explains why some organizations and some leaders are able to inspire where others aren't. Let me define the terms really quickly.
Condition 2 is noisy speech, and for this, I added some hospital noise to the TED Talk audio clips. This will simulate speech recognition software used in a noisy environment. Here's an example of what this sounds like.
If you hire people just because they can do a job, they'll work for your money. But if you hire people who believe what you believe, they work for your blood and sweat and tears.
Condition 3 is accented speech, and for this I used Spoken Wikipedia and found some articles that were read by people with Chinese and Indian accents. Here's an example.
The HSK is held regularly in China and in other countries each year, and the HSK certificates are issued to those who meet the required scores. The HSK is scored on a scale of 1 to 11.
Finally, condition 4 is specialist and technical speech. For this, I took some abstracts of papers that were recently published on arXiv. They're in various topics like machine learning, pure mathematics, and physics. And I used the ElevenLabs text-to-speech system to synthesize them into speech. Ideally, we should have human speech for this, but I figured that ElevenLabs is not affiliated with any of the models that we're benchmarking, so it shouldn't give an advantage to any of the contenders. Here's an example.
First, we derive a well-behaved, regularized relativistic GAN loss that addresses issues of mode dropping and non-convergence that were previously tackled via a bag of ad hoc tricks.
These 4 are only a small sample of possible speech conditions. So in this test, I'm ignoring anything involving conversations between multiple speakers, and I'm also ignoring other languages, mainly because they're not relevant for the VoiceWriter application. But let me know in the comments if you think there are anything that would be interesting to benchmark. Now let's talk about the models and APIs we're benchmarking. First, let's do the startups, the Assembly AI and DeepGram. Both of these are very convenient to get started. They have tutorials that show you exactly how to upload a file and get it transcribed in a variety of programming languages. By the way, if they ever have a case where there are multiple possible models to use, I always choose the one that's advertised to have the highest performance, and I use the default settings for everything. Both Assembly AI and DeepGram claim that their speech recognition models are better than the other one, and also better than everybody else's. So we'll soon see which one is true. Next, we have the 3 big cloud providers, AWS, Google, and Microsoft Azure. Each one of these have various AI capabilities, including speech-to-text. The way you run them is a bit more complicated than the startups though. Instead of being able to just upload an audio file to transcribe, you have to somehow upload a file to a cloud bucket somewhere, and then run a transcribe job to input a certain cloud bucket and output to a different cloud bucket, and then download the file from the cloud bucket. And there's a bunch of work you have to do to make sure that each of the cloud buckets has the right permissions and the transcribe job can access the right file buckets and so on. And figuring this out 3 different times for these cloud providers, I would say is by far the least fun part of this whole process. Now, if you're developing an application and you already have a bunch of data in S3 buckets, and you want your data to be stored into S3 buckets, then this will be really convenient. Otherwise, if your data is not already in S3, just be aware this is going to be more difficult to implement than one of the startups, Assembly AI or DeepGram. The next model is the OpenAI Whisper model for speech-to-text. And this is the only open source model that we'll be looking at in this benchmark. This model can be run locally, so we have a few choices on how to run it. The first setup I tried was using Faster Whisper to run the Whisper Large v3 on my GPU. It is possible to run the smaller Whisper models without a GPU, but for the largest Whisper model, a GPU is required to get any reasonable speed. An alternative setup is running it on a cloud, and this can be done without a GPU. Various API providers offer the service of running the Whisper model on the cloud, including DeepGram. I found that the DeepGram hosted version of Whisper performs slightly better in my experiments, so I'll be using that for the rest of the video, but the differences were very small, like less than 0.5%. And last but not least, we'll be looking at the Gemini model. This one is a bit different from the others. It's not a specifically speech-to-text model, but it's a multimodal LLM that supports speech. How it works is you give it a speech, convert it into tokens, and then here you also pass in some kind of prompt like, please convert this speech into text, and then it outputs the text. Combining speech and text in this way is a fairly new concept, but we might be seeing more of this in the coming years. And if you're curious about how this works, I have a video here about how speech LLMs work in more detail. At the time of recording this video, out of the large LLM providers, only Gemini is able to take audio as input, but there's a good chance that OpenAI and Anthropic will have this capability by the time you're watching this video. Anyways, I benchmarked the Gemini 1.5 Pro model, and I also tried the 2.0 Flash experimental model. These two performed fairly similarly in my experiments, but for the sake of this video and keeping it simple, we'll just go with the 1.5 Pro model. For the evaluation metric, we'll be using WER, or word error rate, which basically counts the number of insertions, deletions, and substitutions relative to the length of the string. There is an important detail about how we count capitalization and punctuation errors. In this example, there are numerous differences in the punctuation and the capitalization. There's also differences in how to represent the number 2, and some words like the word color, which can be spelled differently depending on the dialect. In order to control for these differences, sometimes a normalized version of WER is used. In the normalized WER, we remove all punctuation and capitalization and standardize spellings of words and numbers so that these are not counted as errors anymore. This is useful for getting a more pure sense of this raw speech-to-text accuracy without any ambiguities like punctuation and capitalization. Both forms of WER are useful for different purposes. Formatting is usually important to get right when we're using a speech recognition to write something like in a written document. But in many cases, when the text is an input to a downstream system like a voice assistant or a machine learning algorithm, then the formatting is going to be stripped anyways. And we don't really care about the formatting accuracy, and we just want the system to output the words correctly. Since both metrics are useful for different purposes, we'll be including both in this video. Now for the results that we've all been waiting for. Let's start with a clean speech. When formatting is not required, all of the models do fairly well, with all the word error rates on average below 10%. This is to be expected since this is a fairly easy setup, and we'll see soon that in more challenging setups, the different models will have vastly different performances. When formatting is required, we see that across the board, the word error rates tend to be around 10% higher, and also there's more of a difference between the better and the worse models. The winner of the clean speech category is Whisper, coming in first in both formatted and unformatted cases. And the runner-ups are DeepGram and Gemini, both within 2% word error rate of Whisper. Assembly AI comes similar to Whisper in terms of raw accuracy, but struggles a bit when formatting is required. Next up, let's look at the results for noisy speech. And most models here perform a little bit worse, around 1 to 2% worse, which is not too bad considering the amount of noise that we added. There's a little bit of shakeup in the rankings, since Assembly AI, Whisper, and Amazon handle noise a little bit better than the rest. The models by Microsoft and Google struggle a little bit more with noise, coming in last place in these categories. The overall winner again is Whisper, coming in first when formatting is required, and tied for first place with Assembly AI when formatting is not required. Assembly AI comes in second place, and Gemini as well does not do too bad in this category. How about for speech with non-native accents? In this category, the clear winner is Gemini, which places first whether or not formatting is required. Beyond Gemini, Whisper and Assembly AI, and also Amazon, do reasonably well at recognizing speech with accents. And again, coming in last place is Google's model, with a disastrous performance of an average performance of 35 word error rate at recognizing non-native English speakers. Now what about speech with a lot of technical and specialist vocabulary? In this category, the winner once again is Gemini, which comes in first place in both the unformatted and formatted categories. This category, I think, is where large language models can really shine and show their superiority over special models that just do speech-to-text, because they have the knowledge to understand how these technical terms relate to each other and how they're spelled. Honorable mentions in this category are Assembly AI and Whisper, which do better than the other models at recognizing technical speech. I was surprised by the fact that some of these models have even lower word error rate on this sample than clean English speech, probably because of the fact that these samples were synthesized so it has the least amount of noise. Anyways, here are the overall rankings. Averaging across all categories, the best two models are Gemini and Whisper. These two models are basically tied for first place, although Whisper is a little bit better at handling noise, and Gemini is a bit better at handling accents and specialist speech. And overall, the ordering of these models are reasonably consistent, no matter what kind of speech we are evaluating and whether we're considering formatting or not. No matter what, we always see Google being in last place and Microsoft being in the second last place, and the first place switches between Gemini and Whisper. DeepGram and Amazon models are consistently in the middle of the pack. Assembly AI is very strong when formatting is not required, sometimes even coming in first place, but is a little bit weaker at generating the correct punctuation. I was surprised by Google ASR's performance, which consistently comes in last place. The difference was so big that at some point I was wondering if I made a mistake somewhere in the configuration or something. So I looked for some other benchmarks of people who compared these systems, and every time I found that Google is consistently in last place. Like in this comparison by DeepGram, as well as this comparison from an academic paper. Google is always in last place, sometimes by a very big margin compared to everything else. Now, I don't really know what's inside Google, but if I'm just speculating, probably they're putting their best and brightest machine learning folks on the Gemini project. So this project is getting the best models and the best data, and the cloud speech-to-text is probably not being actively maintained, so it's falling further and further behind. But if any of you is watching this and have some information about what's happening in Google, I'll be really curious to know whether this is the case. We have so far been focused on batch ASR, so you upload a file and you get a transcript from the service. But I was also curious, what was the best APIs for real-time streaming ASR? The difference is, instead of uploading an entire audio clip at a time, we stream it to the service in real time. So the latency needs to be around 1 or 3 seconds, and because it doesn't have the full context when it's processing the audio, we can expect the accuracy to be a few percentage points lower. Which one of these models can do streaming? Well, actually most of them except for Gemini, which currently does not support any kind of streaming. For each of these models, the way you run the streaming API is different from the batch API. And I wasn't too impressed by the Google and Microsoft batch APIs, so I decided to not do more work of integrating the streaming APIs. Not that it's really difficult, but honestly, I was tired of doing API integrations at this point. Anyways, the three that I benchmark is AWS, Assembly AI, and DeepGram. And the OpenAI Whisper model, it kind of has a streaming version. What's happening with the Whisper model is it's not really meant to be a streaming model, but people have come up with clever ways of making it into a streaming model. One repo that does this is Whisper Streaming. And if you want to know more about how this works, I have a video here about Whisper Streaming and how it turns Whisper into a streaming model. Please go watch it if you're curious about how this works. Anyways, I use this repo using Whisper Large v3 and the Faster Whisper repository for inference on GPUs, and everything I use the default settings as always. So here are the results. And right away we can see that the streaming models, they all have a pretty substantial drop in performance compared to the non-streaming models. In the formatted case, the drop in performance is around 6 to 7%, which is pretty bad. But in the unformatted case, if formatting is not required, then the drop in performance compared to the batch model is more like 3%. The Amazon and Assembly AI models are about equal, and they're the best models for real-time streaming as long as formatting is not required. And both of these models are substantially worse at generating formatting while real-time streaming. And when I examine the outputs, I think trying to generate formatted sentences while streaming is fundamentally pretty hard. Here's an example from Assembly AI, which has the worst case of this issue, but it's an issue that affects all of the real-time streaming providers. The problem is when we're trying to generate punctuation in real time, it tends to generate a lot of really short sentences. Like here, I'm counting maybe like 8 different sentences, but in the original, it should be only 2 sentences. And I think it's just kind of hard to predict when a sentence is ending. If the speaker is pausing for like a second or two, whether to predict a period or a comma or nothing at all. And all of the models do this rather poorly, and they predict the wrong punctuation. So that's why in this table, the formatted word error rate is really high for all of the models. None of them are able to get under 20% word error rate, but if formatting is not required, then the accuracy is more reasonable. So if you're developing an application that requires real-time streaming speech recognition, you should probably consider if it's better to strip out the punctuation and capitalization and just deal with unformatted text rather than formatted, because the formatting is going to be so unreliable. Even the best models have like 22 or 24% word error rate. There's one more thing I would like to mention with the Whisper Streamer model. So it's one of the better models for real-time streaming, but there are some outliers because I encountered some reliability issues when benchmarking it. On 2 files, it stopped outputting punctuation all of a sudden. On 1 file, it just dropped a large portion of the file, and on 3 files, I witnessed some hallucinations, like "thank you for watching" in its output when it's nothing like this is said in the audio. These may be fixable, but I wasn't able to fix them by trying a few different configuration options, and it's probably because Whisper streaming is not an officially supported method of running Whisper. It's kind of added on after the model was trained, but I would be a bit hesitant about deploying Whisper streaming in a production setting. Then who are the winners in the streaming category? This, I think, is a little bit unclear, so at least for the formatted case, I would say there are no winners here. And in the unformatted real-time streaming category, the best models tied for first place are Amazon and Assembly AI, since these 2 models have better accuracy than DeepGram and Whisper streaming. Okay, now let's do some final recommendations. How would we rank all of these from best to worst? Before we decide which ones are the best, what's more clear is which ones are the worst APIs, and the answer is pretty clear. Google is F tier. By far the worst is Google Speech Recognition, which comes dead last in every setting that we benchmarked, often by a very large margin. So solidly F tier. Next is Microsoft Azure. I'll put this in D tier because it's not as bad as Google. Might be worth it if you have data that's on Microsoft Azure, but it consistently comes in second last place, which is also not great. Now the winner of this contest is tied between Gemini and OpenAI Whisper. Depending on the setting, one of these models may be better than the others, but in all settings, the first place was either Gemini or Whisper, so they both belong in S tier. Runner-up is Assembly AI, which I'll put in A tier. It's very strong at unformatted text, but it's a little bit weaker at generating proper sentences. And finally, AWS and DeepGram I'll put in B tier. They're pretty solid options, especially AWS if you have your data stored in AWS. And these 2, AWS and DeepGram, are consistently in the middle of the pack in all of our benchmarks. Next, the award for best real-time streaming API goes to AWS and Assembly AI. But I would recommend stripping out the formatting before using the output because the punctuation is so unreliable. Maybe this will change in the future, but at this moment, I don't think any of these APIs are good enough at generating formatted sentences and punctuation in real time. That's it for this video. It took me a lot of time to run these experiments, so I would really appreciate it if you could drop a like and subscribe to my channel. And don't forget to ring the bell to stay notified when I make similar videos like this in the future. That's it. Goodbye.